Hi, this is Alicia Benson, and my presentation is on ocean acidification. Prior to the Industrial Revolution, the ocean's pH was approximately 8.2. Today, the ocean's pH is about 8.1. This may not seem like a great change, but this change is about a 25% increase in acidity. Ocean acidification is the decrease in the pH of our oceans. This is due to pollution caused by both man-made and natural sources. This increase in acidity in the oceans harms our marine life, affects the biodiversity of the ocean, and can cause an overgrowth of algae. Ocean acidification is largely due to emissions in our atmosphere. Gases such as carbon dioxide, sulfur dioxide, and nitric oxide form acids that contribute to the decreasing pH of the oceans. Carbon dioxide dissolves out of the atmosphere and reacts with water to form carbonic acid. Sulfur dioxide reacts with oxygen in the air to form sulfur trioxide, which then reacts with water to form sulfuric acid. Nitric oxide reacts with oxygen in the air to form nitrogen dioxide, two molecules of which then react with water to form nitric acid and nitrous acid. All of the products of these common gases reacting with air and water create acids which go into our ocean, making it less inhabitable for our marine life. These gases are produced from a variety of sources, including volcanoes, forest fires, and burning fossil fuels. Approximately 0.5% of the pollution in the ocean is from volcanoes. Carbon dioxide and small amounts of sulfur dioxide can come from volcanic vents that lay in the water, as well as volcanic eruptions that release gas directly into the atmosphere. Forest fires can form carbon dioxide, nitric oxide, and nitrogen dioxide that contribute to ocean acidification. In addition, forest fires are a cause of deforestation, which takes away a natural resource that fights atmospheric pollution. Although volcanoes and forest fires contribute to ocean acidification, the biggest factor is burning fossil fuels. The burning of fossil fuels releases gases such as sulfur dioxide and nitric oxide that creates strong acids, but the biggest contributor to ocean acidification is carbon dioxide from burning these fuels. According to the U.S. Energy Information Administration, in 2019, we released 33.1 billion metric tons of energy-related carbon dioxide around the world. Approximately 30% of this carbon dioxide that is released into the atmosphere is absorbed by the ocean. Therefore, the more carbon dioxide that is released into the atmosphere, the more the ocean will absorb. The carbon dioxide that is absorbed from the atmosphere reacts with water and carbonate ions to make two bicarbonate ions. This consumption of carbonate ions impedes calcification, which results in shell-building organisms having fragile, soft shells. Carbonate ions are an important building block for seashells, coral skeletons, as well as other shell-building organisms. They provide strength and rigidity to the organism's shell or skeleton. The decrease in carbonate ions can make building and maintaining shells and other calcium carbonate structures difficult for organisms such as oysters, clams, sea urchins, and certain plankton. We are already seeing the effects of ocean acidification in the Pacific Northwest. Research conducted by NOAA showed that the Dungeness crab that were pulled from the Pacific Northwest had sensory damage from decreased pH levels that affected their ability to orient themselves, regulate buoyancy, and avoid predators. This can affect the biodiversity of the oceans because it can throw off the balance of our food chain. Organisms at the bottom of the food chain that are not affected by ocean acidification can overgrow as their predators diminish. This can even affect predators at the top of the food chain, as some of their food sources, such as crabs and fish, are declining in population due to ocean acidification. Many species of plants and algae prefer an acidic environment. The increased in habitable conditions for algae and the decrease in habitable conditions for algae's predators, such as crabs and fish, could lead to an overgrowth of bloom-forming algae in our oceans. In conclusion, ocean acidification harms our marine life and affects the biodiversity of our oceans. This is mainly due to anthropogenic carbon dioxide pollution. The carbon dioxide pollution increases the amount of hydrogen ions in seawater and decreases the concentration of carbonate ions, which make it difficult for shell building organisms to sustain life. Although ocean acidification is not easily reversed, there are actions we can take to reduce our carbon footprint, such as supporting clean energy sources, reducing consumption of fossil fuels, and choosing environmentally friendly options when possible.